Hello there, my name is Gregory Carlson and welcome to part 2 of section 1.2 in college algebra. You'll be happy to know this next problem I think is a little easier than that distance rate one we just did. It says the second side of a triangular deck is 3 feet longer than the shortest side and a third side is 3 feet shorter than twice the length of the shortest side. Good grief. If the perimeter of the deck is 56, what are the lengths of the three sides? So as usual, the first thing you should do in a problem like this is draw a picture. So I'm going to draw a triangle and I'm going to kind of make the lengths all be different sides because I don't know if they're the same or different. So let's call one of the sides A, one of the sides B, and one of the sides C. So in order to find out, we want to know what are the lengths of this deck, and we need an equation to do that, and they tell us that the perimeter is 56 feet. So your first equation just falls in your lap. It's A plus B plus C equals 56. Because the perimeter is all of the sides added together, the distance around the shape, so A plus B plus C is 56, and A, B, and C could have a lot of different values to make this true, so we need to use the rest of the information in the problem to find the actual lengths. So let's see. It says the second side is 3 feet longer than the shortest side, and the third side is 3 feet shorter than twice the length of the shortest side. So here's what I'm kind of thinking. The shortest side relates to all of the other sides. If you look, the shortest side kind of governs everything. So let's take it one piece at a time. The second side is 3 feet longer than the shortest side. So let's call C our shortest side. Again, the way I recommend you do this is to actually write B equals C, even though we know that's not true. So we're just going to write B equals C, and now we're going to correct this. So it says the second side is 3 feet longer than the shortest side. So if I have B equals C, B is 3 bigger than this. So if this was 2, then this would be 5. So I either need to subtract 3 from here or add it to the shortest side, and I'm going to add. So B is equal to C plus 3. Now this is correct. Let's use the next piece of information. It says the third side, A, is 3 feet shorter than twice the length of the shortest side. So let's compare A and C now. Again, we'll write A equals C, even though we know that's not true. So it says the third side is 3 feet shorter than twice the length of the shortest side. Well, twice the length, let's do that first. Twice the length of the shortest side, we would just multiply by 2. But then it says that A is actually 3 feet shorter than this. So in fact, A is smaller than this amount right here. So can you think about what you would do? If A is smaller, this is the weaker side, so we either need to add 3 here or subtract 3 on this side. So our second equation is our third equation is A equals 2C minus 3, because this A, it says, is shorter, 3 feet shorter than twice the length of the shortest side, so 2C minus 3. So now we have all the information we need, and you'll notice that I have C everywhere. I have a C here, I have B in terms of C, and A in terms of C. So I want to substitute into this top equation. So let me actually rewrite it. A plus B plus C equals 56. So I know that let's start with A actually. A equals 2C minus 3. A is the same amount as 2C minus 3. So I can replace this A with 2C minus 3. Okay, A just got replaced by 2C minus 3. Now what about B? B equals C plus 3. So I can replace B with C plus 3. And I'm putting them in parentheses just to be safe. And then finally, C we can leave alone, because C equals C. And look at that. We now have one equation with one variable, which is our goal all along in these problems, because now we can solve this. So these parentheses are just not doing much for us. There's an addition sign here, so let's just drop them. 2C minus 3 plus C plus 3 plus C equals 56. And now we can solve this equation. So let's combine like terms. 2C plus C is going to be 4C. And negative 3 and positive 3 are actually just going to cancel, so that's kind of nice. So we're going to get 4c is equal to 56. Divide by 4, divide by 4. So c is equal to 56 divided by 4, which is equal to 14. So that's the hard part, is getting that first value. Once we have one, we're going to be able to find the other ones really easily, because b equals c plus 3. And we know that c is 14. So that means that b equals 17. And we have a equals 2c minus 3 from before. And we know that c is equal to 14. So let's plug that in. A equals 2 times 14 minus 3. Order of operations here, 2 times 14 is 28. So a equals 25. And that's how you do it. So to me, the hardest step of this is just setting up the three equations. But with practice, and if you use my trick of doing it incorrectly and then correcting it, I think you'll be able to get the answer with some practice. And again, I spent a lot of time explaining all of this, but with practice, you'll be able to just go boop, 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 and then get on your way. So let's move on to the next page and do our favorite, which are mixture problems. So mixture problems can be tricky, but let me show you how to do them. It says, how much water should be added to 10 milliliters of a 6% alcohol solution to reduce the concentration to 5%? So how much water should be added to 10 milliliters of a 6% solution to reduce the concentration? So the way you would do this problem is, you want to remember that with these concentration problems, excuse me, you always want to do the percent times the amount to find out how much alcohol is in this solution. So 6% of 10 milliliters is going to be 10 times 0.06. That's 6% of the 10 milliliters. Now that's what we have, and we want to know how much water are we going to need to add to make it 5%, I mean. So we write 10 plus x, because we're going to be adding some unknown amount to the 10 milliliters. And what concentration is this? That's right, it's 0.05. So that's how you set up the formula for this. And these mixture problems are all pretty similar. We'll see a few more, but they're all, it's just the amount times the percent. So we have a 6% of 10 milliliters, and we want to know how much do we need to add this x amount so that the concentration falls to 5%. So let's do it. 10 times 0.06 is 0.6. And we can do the distributive property here. So 0.05 times 10, if you need the calculator, it'll just move the decimal over. It should be 0.5. Yep, 0.5 plus 0.05x. So there we go. We have 0.6 equals 0.5 plus 0.05x. Now let's solve this. You could multiply by 10 or by 100 to get rid of the decimals, but this is easy enough. I think we can just subtract 0.5 on both sides, giving us 0.1 equals 0.05x. And then we can just divide both sides by 0.05. So x is equal to, and can you do that in your head? What would 0.1 divided by 0.05 be? How many 0.05s do we need to make 0.1? Can you do it in your head? It would be 2, because 0.05 doubled would be 0.1. So x is equal to 2 milliliters, and that's where we could stop. So that's how you solve these mixture problems. If we had 2 milliliters, we would have 12 total milliliters of a 5% solution, and that would have the same amount of alcohol as 10 milliliters of a 6% solution. So the key is the alcohol is the same on both sides of the equation. So I'm sure you're doing this for scientific purposes to do this calculation, because that's all that you use alcohol for, right? All right. Anyway, so I'll see you in part 3. We have 2 more problems to go, and see you then.